Good morning, good afternoon, or good evening, depending on where you are joining us from. Thank you very much for your time. My name is Sean Maritz. I'm a Senior Solutions Engineer for the NGINX Business Unit, which is part of F5. And today I'm going to be continuing the conversation around microservices and talking about NGINX Service Mesh. So what is a service mesh? A service mesh essentially provides you with layer 7 traffic management and security within your Kubernetes cluster. It does this by introducing sidecar deployments, policy management, and application availability and health and observability into your Kubernetes deployment. A service mesh isn't just one thing. It's a lot of managed and dependent components that come together to actually deliver the service mesh. It takes over with the Kubernetes networking stops. It's essentially traffic management for your containers. So where does a service mesh fit? Mike Holland on our previous session provided us with some details around NGINX App Protect and the NGINX Kubernetes Ingress Controller to manage the traffic coming into your Kubernetes cluster, which we term as north-south traffic. When we talk about NGINX Service Mesh, this is where you manage your traffic within the Kubernetes cluster, or we term this as east-west or service-to-service communications between your services and pods. With this oversimplified diagram, we can talk around how where Kubernetes sort of stops with the traffic management and where NGINX Service Mesh takes over. So when traffic enters the cluster via the NGINX Ingress Controller, it does this via layer 7. But once it goes from the Ingress Controller to the service and in turn from the service to the pod, this is done via layer 3 and layer 4. This might be okay if your application is simple and you don't really need that end-to-end encryption. But let's face it, in today's landscape and security postures, you kind of want to introduce a level of security or end-to-end encryption within particularly your public-facing applications. The addition of a service mesh gives you the ability to manage traffic within the Kubernetes cluster at a layer 7 level. I'd just like to highlight some of the use cases of NGINX Service Mesh. So what it does is it introduces mutual TLS, so securing traffic in a zero trust network. It provides instrumentation to essentially monitor the performance, latency, and the availability of your applications. It introduces tracing, so you can debug the transactions and locate faults within the application. You can introduce rate limiting as well to provide or to protect your vulnerable applications from greedy clients. It also allows you to introduce traffic splitting. So if you're wanting to do A/B deployments or canary testing or blue-green deployments or upgrades to your applications, you can do this using the NGINX Service Mesh. You can also provide access controls, so to implement the allow lists to accurately govern the traffic within your Kubernetes cluster. The other component that NGINX Service Mesh introduces is the egress control, so the ability to manage and broker the traffic to external services from the actual Kubernetes cluster as well. Some of the reasons why you may actually like NGINX Service Mesh is it's really developer friendly. So the ability to set your security policies, definitions, enforcements, and governance very easy to do with the actual NGINX Service Mesh. It is also something that doesn't actually have to be managed and deployed by the infrastructure team. And there's also no manual configurations. It's built on native Kubernetes tooling and also uses other open source tools for the observability, security components, etc. It's powerful and efficient, so it's the fastest, lightest way to get MTLS traffic management into your microservices environment. And there's also no sidecar injection required for the actual ingress controller. When we look at the NGINX sidecars, it's a fully integrated high-performance data plane for high available and scalable containerized environments. So it brings the world's best software reverse proxy into your container traffic management. When we look at the architecture of the NGINX Service Mesh, there's a few real key advantages here. It's very infrastructure agnostic, so it doesn't matter whether you want to run this on AWS or Azure or Google Cloud, whether you want to run it in a private cloud or public cloud or on bare metal inside your own data center. It doesn't matter where you want to deploy the service mesh. When we look at the control plane, it provides dynamic support and management of the apps in partnership with the Kubernetes API. It reacts and updates applications as they scale and deploy so that each workload instance automatically stays protected and integrated with other application components. It's essentially a set and forget style of deployment of a service mesh. So it lets you focus on more valuable business solutions. When we look at the data plane, NGINX Plus as a enterprise-grade sidecar for your application workloads provides a seamless and transparent capability for load balancing, reverse proxying, traffic routing, identity, and encryption features needed for production-grade service mesh deployments. It integrates natively with the NGINX Ingress controller for a unified data plane where you can centralize and streamline your configuration of traffic management. Unlike other management, like other meshes, as mentioned earlier, NGINX Service Mesh doesn't need to inject a sidecar into the Ingress controller. When we look at the observability plane, NGINX Service Mesh supports open tracing and Prometheus, and also comes with a ready-to-use Grafana dashboard so you can visualize metrics with detail down to the millisecond, day-to-day overlays, and also understand what's happening with your traffic spikes. Some of the NGINX Service Mesh use cases are really there to secure your traffic, so end-to-end encryption and MTLS and access control list policies within your Kubernetes clusters. It's a lightweight control plane, as mentioned. It's a very small footprint and very developer-friendly control plane, again, so that you can deploy it as a set and forget kind of deployment within your Kubernetes cluster. You can also understand your load balancing algorithms and really have an enterprise-grade application delivery controller within your Kubernetes cluster. NGINX being a well-proven solution, not only in the containerized, but application delivery space as well. And then you can also visualize your traffic with the Prometheus, Grafana, and uses the SMI spec for portability. So it's easier to actually replace existing service meshes with NGINX Service Mesh. And it's also completely open. So if you want to use your own visualization tools to understand what's happening within the Kubernetes ecosystems, you can use your own observability tools for that as well. So with that, I'm going to take us in through a bit of a demo on NGINX Service Mesh and see what are some of the capabilities and how it can be used within a Kubernetes cluster. All right, so what we have here is a 4-node cluster, so one master control node and 3 worker nodes. We have a look at the pods running. We have the standard Kubernetes pods running. In this directory, I've got my service mesh images, so you can actually download these images so you can load them into a local repository. We've also got the service mesh binary. So next steps is we're going to take the NGINX service mesh binary, we're going to extract it. And before that, let's just export the version number that we'll be using, which is version 1.2.1. Next step is we are going to take the NGINX Service Mesh, we're going to extract the binary and provide it with the correct permissions to run. There we go, we can see the mesh control binary is there. You can see I've got the appropriate permissions to read, write, and execute. Right. Next step is to actually use the NGINX binary and NGINX Service Mesh binary to deploy the service mesh. So I'll run that. And you'll see that there's the components that are starting to run. So the likes of Spire, which is for your certificate management, and MTLS. We've got NATS, the message bus servers running. There's the metrics API server, etc. And as we see the pods spin up, they're running, and we can see that the service mesh is all up and running. just going to move that out the way. Okay. I'm going to check the version. Because I'm just running the bind in the local directory, we can see NGINX Mesh Control version 1.2.1 is up and running. Let me just clear this. So I'm going to have a look at and see what is actually going to automatically inject a sidecar into a namespace. So you can see here that I've got enabled namespace is book info. It says is auto inject enabled, which is false, which means that I need to define which namespaces I'm going to inject the sidecar into the actual the pod. Right. So what I'm going to do is I'm going to download this application, which is called book info. It's quite often used at Istio for examples, and I'm going to deploy this application and into that namespace, which was the book info. Oops. All right, now that's created. Let's just clear this. Now I'm going to actually show you what's inside these pods. Now, when we list these pods inside this application, we can see here that there's the actual book info reviews, we've got the book info product page and so on, but next to each of these containers is a sidecar from the NGINX Service Mesh. So the NGINX Plus being run as a sidecar within that, that next to that container, so that it will actually take all the layer 7 traffic and manage the traffic communicating between those containers over a layer 7, as opposed to traditionally layer 3 and 4 on Kubernetes. I'm going to create another namespace, book info no inject, and what I'll do is I'll deploy the same application into the namespace book info no inject, and we'll see that these containers are created. And we'll have a look at those pods inside that namespace, and you'll see that there's one container running in each pod. I'm going to create another namespace called book info manual inject, and this time I'm going to manually inject that book info.yaml into the namespace for book info manual inject. So when we have a look at those containers now, we can see that those containers are now running as a sidecar inside that deployment. If we have a look at that, we can see the sidecar running there. So just to remind you that when we looked at the namespaces that we are auto injecting into, we defined that inside the configuration. With a manual injection, I manually injected those into those containers, and we can see that the NGINX Service Mesh has been deployed inside that particular pod. And we'll And if we have a look at the differences between the files, there's quite a bit that gets added to the manifest file when you are manually injecting it. So it does add a bit of information there, but the command line that you use to manually inject is pretty straightforward to use, and just injects all that data into the actual YAML file, so that it's relatively straightforward to use. I'm just going to have a look at all the services, and I can see that my services are all running, and these are the NGINX Service Mesh services. So anything that I've applied a service mesh configuration to is listed there. I'm just going to send a request quickly to the book info ratings. And we can see that I get an XMesh request ID. So every request that is sent via the service mesh does get its own ID. Now what I'm going to do is I'm actually going to start throwing some traffic through this service mesh so we can see performance and some other information around what's happening inside the service mesh as well. First thing I need to do is just do a port forward to the Grafana service so we can actually have a look at the dashboard. The next step was I'm just going to include the actual NGINX top so we can see the kind of traffic it's going through. You can see incoming success 100%, outgoing success 100%. Now I'm just going to bring up a browser that we already have the Grafana dashboard preloaded into. And we can see that at the moment I'm getting 117 odd requests per second, 116, and the number of pods that I'm monitoring is 12. If I look through all the requests per second, and each of the containers are listed inside that graph. And of course you can go and customize these dashboards. This dashboard is sort of stock standard with what comes with the NGINX Service Mesh. And will provide you with a lot of telemetry that you're looking for. But again, you can pipe this into your own monitoring and monitoring tools and analytics tools, etc. So while we are monitoring this, I'm going to delete a pod inside the book info namespace, and we'll see that if we look at the actual number of pods being monitored, it's going to drop down to 10. We'll see there is a bit of a service degradation there, but that pod will come back up. And when we go back to the container or back to the dashboards, see it's dropped down to 10, and as that pod recovers, it goes back up to 12. So what we'll do is we'll actually do that delete while we're actually watching these pods, so we can see those pods drop off. Alright, so we'll watch these pods now while we're deleting that one. We can see that one is pending, deleting, terminating. And we've got pod initializing and up and running. So it's relatively quick in actually responding to those down pods. We can see that it's now settled back into the dashboard at 12 pods. But what we'll do next is we will delete one of those, go back to the dashboard, and that dropped down to 11 and reinstated itself in the collection of pods that are running. Right, while those requests are going, we'll do something else here. We will let's scale it. We'll introduce more replicas of the ratings pod. Let's have a watch of what's actually happening on the book info. We can see that the pods are initializing, scaling up, and if we have a look at the dashboard again, those are up and running. If we go to the dashboard, we can see that number of pods that are being monitored increases. Pretty straightforward. So what I'll do is I'm just going to scale this back down. Those two are terminating, and of course it'll be reflected back in the dashboard again. There we go, 12 pods. Can start with this. I'm going to look inside the actual container itself. You can see the NGINX configurations are very much stock standard. They really are. The service mesh is just a pre-configured version of NGINX Plus, which are really catered towards your Kubernetes environment, so that you can really have those that layer 7 MTLS protection between your containers by defining the appropriate policies, understanding or letting the services discover and dynamically reconfigure the NGINX Plus instance to understand what's happening inside the environment. I'm going to create another namespace called test tools injected, which seems like it already exists. And test tools, which already exists. I'm just going to get all the namespaces. Yeah, you can see that test tools and test tools injected is up and running there. Now what I'm going to do is I'm going to clear that, and we'll have a look at the NGINX configuration for what's actually enabled for auto injection. But I'm going to have to port forward to the NGINX Service Mesh API so that I can actually do a reconfiguration using an API request. There we go, that's up and running. And from here, what I'm going to do is I will send an API request, or I'm going to update the actual configuration of the namespaces that are going to automatically inject. So here we've got my JSON file. I'll just paste this here, and we can see that I'm introducing the additional namespace. I'm going to send this JSON file to the NGINX Service Mesh API. So this can be dynamically configured via an API request, really well suited towards your CI/CD pipelines. I named the file incorrectly, so let's try send that again. And there we go, a response. So there's details of the service mesh. And now if I go and actually look at the namespaces that are enabled, we can see test tools injected has been enabled as a namespace. It'll automatically inject sidecars when deploying into that namespace. All right, clear that. Now, getting rid of the service mesh is relatively straightforward. I just go to NGINX Service Mesh control, remove it. And if we actually watch, I'll close these two windows. And we'll have a look at the pods that are being deleted. And we can see that service mesh Spire server is deleted. Most of the other service mesh containers have been deleted as well. You can still see our book info has got its sidecar still in place. And to remove the actual sidecar, I mean, it's not going to stop working at this stage, but to remove the sidecar, you'll need to re-roll the application out. So let's have a look at how that's done. Yeah, as you can see here, we got the NGINX sidecar still in place in that book info namespace. So we'll re-roll this application. So if you have a look at the actual pod, or when you send a request, it is now going via directly to the container. So it's not actually going via the sidecar. So we've removed the service mesh, but that container is still running. This is where the process of actually re-rolling the application comes into play. Yeah, we can see those both running. So to fix this, it's pretty straightforward. Let me actually add a watch to this, and we can have a look at what happens when we re-roll that application. Watch that. And we can see that sidecar containers and the application containers are now terminating, and of course the new ones have spun up already, so really no disruption to the services at all. So that's really it for the NGINX Service Mesh. Look, it's a great way to get that turnkey solution into your Kubernetes environment to ensure that you have that MTLS security. It's all too often that we find customers that have gone to the trouble of creating Kubernetes applications, go to deployment, and then having security come back and say there's a red flag on your application because of end-to-end encryption. So as you can see, it's very straightforward to actually deploy. It really is a set and forget type of deployment. You can have it auto inject into all your deployments, or manually inject it, or have allowances for some namespaces not to have auto injection. So I do hope that you found this useful. Please do reach out to us if you have any questions, and we are looking forward to seeing you at the next event. Thanks.